In this video, we will discuss how to graph any equation that's in the form y equals a times the sine of b times x. To graph an equation in this form, you first have to be familiar with the graph of y equals the sine of x. The graph of y equals the sine of x is shown on the screen, or at least one cycle of the graph is shown on the screen, because the shape that's graphed in red repeats itself to the left and to the right indefinitely. One cycle of the graph of y equals the sine of x begins at the origin 0, 0, and one cycle ends after 2 pi radians. When graphing trig functions, usually the x-axis is labeled in radians because the angle x in y equals the sine of x is thought of as being an angle measured in radians. The y-axis here is measured with the integers. The graph of y equals the sine of x again begins at 0, 0. It will rise 1 unit above the x-axis and return to the origin after pi radians before dropping 1 unit below the x-axis and returning to 2 pi. This shape would repeat itself infinitely to the left and right. If I would zoom out or continue this graph past 2 pi, the exact same shape would occur between 2 pi and 4 pi radians. Every 2 pi radians, this shape would repeat itself. Not only to the right, but also to the left. If I were able to continue this graph to the left, this shape would repeat itself 2 pi units to the left. The graph of every equation in the form y equals a times the sine of bx is based on the graph of y equals the sine of x. In this video, we'll talk about exactly how that manifests itself when we draw the graph of a few sine functions. For example, we'll talk about the graph of y equals 2 times the sine of x, where the value of a is 2. Y equals the sine of 2x. In this case, the value of b is 2. Y equals the sine 3 times the sine of x over 2. And y equals negative 2 sine of 1/4 x. At the conclusion of this video, you should feel comfortable graphing any equation of the form y equals a times the sine of bx. A and b are real numbers. A cannot have a value of 0. If a was 0, this would basically be the graph of y equals 0, a horizontal line. And the value of b will be a positive real number. Let's begin. Let's begin by talking about how a value of a affects the graph of a sine. We'll do that in drawing the graph of y equals 2 times the sine of x. In this equation, the value of a is 2. The value of a is, of course, 2 in y equals 2 times the sine of x. We can use a to find what is known as the amplitude of the equation. An amplitude, this is not a very mathematical definition, but an amplitude is a measure of how high the sine curve is. It's actually, the amplitude is a measure of how high any wave is. We can find a numerical value for the amplitude by taking the absolute value of that number that's multiplied in the front of the sine, the absolute value of a. In the equation we're looking at on the right, y equals 2 times the sine of x, the amplitude of this curve will be the absolute value of 2, which of course is just 2. And what this means is that 2, in the graph of y equals 2 times the sine of x, 2 is the number of units from the vertical center of the graph that the curve will go to its highest point and to its lowest point. It's the number of units from the vertical center to the highest and lowest points of the graph. If you remember, when we looked at the graph of y equals the sine of x, this is y equals the sine of x again. This one, from its vertical center, rises 2 units before falling and getting to its lowest point of negative 1 units. The graph of y equals 2 times the sine of x will be very similar to this graph, except instead of going up 1 unit and down 1 unit, Instead, since its amplitude is 2, it will rise 2 units and fall 2 units. Let's draw the graph and see how that manifests itself in the graph of y equals 2 times the sine of x. Again, the amplitude of this equation is 2. So when I draw this graph, I'm going to begin by drawing one cycle of the graph. It's going to start at the origin, and it's going to end, or at least one cycle of the graph will end after 2 pi radians. The middle of the graph, the middle of one cycle of the graph, occurs at pi radians. Now, halfway between 0 and pi, halfway between the beginning and the middle, this will rise to its highest point, which is 2 units in this case. If the amplitude is 2, that's how many units it will rise above the origin before returning back to the origin at pi radians. Then it will also fall that same number of units. The amplitude is 2. It's going to fall 2 units, and it's going to reach that lowest point halfway between pi and 2 pi, which is 3 pi over 2, before returning to the origin, or returning to the x-axis rather, at the point 2 pi 0. What you see on the screen right now is one cycle of the graph of y equals 2 times the sine of x. This shape that shows up here between 0 and 2 pi will repeat itself to the left and to the right infinitely every 2 pi radians. Every 2 pi radians, it will go up 2 units, it would come back down to the x-axis, then go down to -2 units below the x-axis, and rise again. This shape will repeat itself infinitely to the left and to the right. Next, let's discuss how a value of b affects the graph of y equals the sine of x. We'll do this in drawing the graph of y equals the sine of 2x. In this equation, the value of b would be 2. Now, a value for a defined an amplitude, which was a measure of how high or low the highest and lowest point on the graph were. The value of b will help define what is known as the fundamental period of the graph. The fundamental period is a measure of how long the curve is. Again, amplitude is how high or low the curve is, and fundamental period is how far to the left and to the right it takes to draw one cycle of the graph. Mathematically, you can find a number to represent the fundamental period by using the equation period equals 2 pi over b. Now, this value for the period, or the fundamental period, will give you the number of units on the x-axis that it will take to draw one complete cycle of the curve. Remember, the graph of the sine of x, the graph of y equals the sine of x, looks like this. In this graph, the fundamental period is 2 pi radians, because it takes 2 pi units along the x-axis to complete one cycle of the curve. But a value of b, other than 1, will change the fundamental period. Perhaps a fundamental period could be pi radians, in which case this entire shape would have to be drawn from 0 to pi radians. Or a fundamental period could be 4 pi, in which case it would take 4 pi radians to complete one cycle of the graph. Let's draw the graph of y equals the sine of 2x to determine how a fundamental period changes the way the graph of the sine looks. So in our equation, y equals the sine of 2x, the value of b is 2. But this is not the fundamental period. The fundamental period comes from the equation 2 pi, period equals 2 pi over b. So the fundamental period, in this case, would be 2 pi over b, 2. 2 pi over 2. Now, what I can do is cross those 2's out. 2 divided by 2 is 1, and I can say that the fundamental period is pi radians. And what I'll do now to draw the graph is I will draw the graph of a sine. One cycle of the graph of the sine looks like this. But from the beginning to the end will be pi radians. So the beginning of this graph, it will start at the origin. There's nothing special happening in this graph. The only thing that's different will be that this shape will end after pi radians, or I'll say one cycle of the graph will end after pi radians. In the middle of the graph, halfway between the beginning and end of one cycle, in this case halfway between 0 and pi, it will cross the x-axis. We'll cross the x-axis. In the first half of the graph, it will rise to the top of its amplitude. And in this case, because there's not a number written in front of the sine, that amplitude is understood to be a 1. So it's going to rise to the top of the amplitude and then return to the x-axis halfway through the fundamental period, which is pi. And then in the second half of one cycle of the graph, it will go down to the bottom of the amplitude, in this case down to -1, before returning back to the x-axis. And here I have one cycle of the graph of y equals the sine of 2x. The fundamental period was pi, so I had to complete one shape of the graph of the sine between 0 and pi radians. Now, the actual graph of this will continue infinitely to the left and to the right, and on this coordinate plane I have enough room to draw another cycle of the graph. Since the fundamental period was pi, one cycle looks like this. I'm going to repeat this shape every pi radians. So from pi to 2 pi, that shape will repeat. From 2 pi to 3 pi, it would be repeated again. From 3 pi to 4 pi, repeated again. Likewise, it would repeat itself to the left. From 0 to -2 pi, this shape would be drawn. I'll go ahead and fill up the coordinate plane that's given on the screen. Every pi radians, repeating this shape. So, as you can see, the graph of y equals the sine of 2x has the same general shape as the graph of the sine, but instead of taking 2 pi radians to draw one cycle of the graph, since the fundamental period was pi, it only took pi radians to draw that shape. Now let's take a look at the graph of a sine, where the value for a and b both are something other than 1. For example, y equals 3 times the sine of x over 2. You should know that x over 2 is the same thing as 1/2 x. And when it's written like this, it's a little easier to see that the value for a is 3 and the value for b is 1/2. When drawing the graph of a sine curve, you want to first identify the amplitude and fundamental period before drawing the graph. The amplitude, the absolute value of a, is 3. The absolute value of 3 is just 3. How about the fundamental period? Well, remember the formula for the period is 2 pi over b. In this case, the value of b is 1/2, so this becomes 2 pi over 1/2. 2 pi over 1/2. 2 divided by 1/2 is actually 4. 2 divided by 1/2 is 4, and so the fundamental period is 4 pi. So, since the amplitude is 3, when we draw this graph, it will go up 3 units from its vertical center and down 3 units below it. Because its fundamental period is 4 pi, drawing one shape of the graph will take 4 pi radians to do. The graph will have exactly the same shape as the graph of y equals the sine of x, which is shown on the screen now. Here's the things that are going to be different. The amplitude is 3 in the graph of y equals 3 times the sine of x over 2. So instead of rising to 1 unit, it'll rise the whole way up to 3 units. And it will fall the whole way down to -3 units. Additionally, since the period is 4 pi, this shape will not be completed after just 2 pi radians. It will take 4 pi radians to complete one shape of the graph. Let's draw the graph now. Because the fundamental period is 4 pi, you would have to use a coordinate plane that goes over at least 4 pi radians on the x-axis, which is what I have on the screen now. And again, remember the shape of every sine graph, if there's nothing added or subtracted at the end, will begin at the origin and end, or at least one cycle of the graph will end in as many units as you found the fundamental period to be. So in this case, we'll begin at the origin. We're not going to end at 2 pi radians. We're going to end, one cycle of the graph, at 4 pi radians. Remember that the graph of a sine will come back to the x-axis, halfway between the beginning of one cycle and the value of the fundamental period. Halfway between 0 and 4 pi is 2 pi. So that's going to be a place where it crosses the x-axis. If I look at the first half of the graph between 0 and 2 pi, it will get to the top of the amplitude, which is 3, halfway between 0 and 2 pi, which would be pi. So halfway between 0 and 2 pi, it's up at the top of its amplitude 3 units above the x-axis before returning to the x-axis at 2 pi. And now it's going to fall 3 units. And halfway between 2 pi and 4 pi, or 3 pi, it's going to be at the bottom of its amplitude. The point 3 pi comma negative 3 would be on this graph. And after it gets down to negative 3, it will rise back up to 4 pi radians. And that will be the end of one cycle of the graph. This is what one cycle of the graph of y equals 3 times the sine of x over 2 looks like. If you're drawing this graph on your own, you would want to extend the graph to fill up the coordinate plane that you've been given, which in this case looks something like this. But all this graph is based on is the one cycle of the graph that we started out drawing. Drawing the graph of the sine from 0 to its period 4 pi radians. For our final example, we'll take a look at a sine graph where the value of a is negative. Y equals negative 2 times the sine of x over 4 is the same thing as y equals negative 2 sine of 1/4 x. Here we have an a value of negative 2 and a b value of 1/4. We begin by talking about the amplitude, and the amplitude is the absolute value of a. So in this case, even though that a is negative 2, the amplitude, the absolute value of negative 2, is 2. An amplitude is always positive. You can think of an amplitude as the height of the sine curve, and a height is always positive. The amplitude is 2. The fundamental period, 2 pi over b, would be 2 pi over 1/4. 2 divided by 1/4 is 8. So our fundamental period here is 8 pi. When we draw this graph, it will be based on the graph of y equals the sine of x. And y equals the sine of x goes as high as 1 unit and as low as negative 1 unit. But because our amplitude is 2, the highest point on the graph of y equals negative 2 sine of x over 4 will be 2 units above the x-axis and 2 units below the x-axis. The fundamental period is 8 pi in our graph. In the graph of y equals the sine of x, this one cycle of the graph is completed after 2 pi radians. When we draw our graph, one cycle of the graph will take 8 pi radians. So our graph will be a lot longer than this one. And the last thing that I have to discuss before we draw the graph is the fact that there is a negative in front of the value of a. Like all functions of the form y equals or f of x equals, if there's a negative on the right side of the equal sign, that's going to be a rotation about the x-axis. Basically, this graph will turn upside down. When I draw the graph of y equals negative 2 times the sine of x over 4, the sine curve that I draw will not look like this. It will be rotated around the x-axis, and it will look like this. Again, a description of that is it's rotated around the x-axis, or you could say it's upside down. Everything that was originally above the x-axis is now below the x-axis, and the parts of the graph that are originally below it are now above. Let's see how that looks when we draw the graph. There's going to be a couple things that are not affected by that negative, and that is that because this graph has a fundamental period of 8 pi, it will begin at 0 and it will end, one cycle of the graph will end at 8 pi. Both of those points will be on the x-axis for sine curves that look like this, that have this form. A sine curve also crosses the x-axis halfway between 0 and its fundamental period. Halfway between 0 and 8 pi is 4 pi. If the negative was not in front of the graph of this negative 2 sine of x over 4, if there was not a negative in the beginning, I would start at 0, 0 and go up. But because there is a negative in front of that value of the sine, I'm going to be starting at 0, 0 and going down. I'm going to start at 0, 0 and go down. So the way that this is going to look is we'll start at 0, 0, and halfway between 0 and the middle of the graph, halfway between 0 and 4 pi, will be at the bottom of the amplitude. We'll be 2 units below the x-axis before coming back to the x-axis halfway between 0 and 8 pi. And then we'll go above the x-axis, the number of units defined by the amplitude, 2 in this case. Halfway between 4 pi and 8 pi is 6 pi. And that's the top, the highest point in this graph before it falls back down again to the x-axis after 8 pi radians, the value of our fundamental period. So on the screen right now in red, you see one cycle of the graph of y equals negative 2 times the sine of x over 4. This shape would be repeated infinitely to the left and to the right. If I had a bigger coordinate plane to work with, I would redraw this shape over and over again to the left and to the right. But on the screen now you can see one cycle of the graph of y equals negative 2 sine x over 4.